have to review this after we come back after the week. Okay, so to estimate the value of your P, which is your population proportion, you use a point estimate of X. False. What is your point estimate for a proportion? P hat. Good. This, my X bar, is my point estimate for my mean. P hat is my point estimate for my sample. I think what confuses some of you is, where does this population thing come from? That's our problem. We don't have any information about the population, but we have to make this inference about the population. And the only thing we can do with that is base it on our sample, which is why it's so important that your sample is a good representation of your population. Because if it is not, you just made the wrong inference. So we need a starting point. So we use from our sample, we do X over N, part over whole, and we find the point estimate, a proportion from our sample. This is what we build our population interval on. In a survey of this many, they say they have this. Everybody can set this up, find the P, find the Q. If not, raise your hand. Same thing with this one. I don't know if yours said 110 or 100. Did yours say 110? Okay, never mind. So 110, everybody's okay with that? Find your Q. Now, technically, we do N times P is greater than 5, equal to 5, N times Q is greater than or equal to 5. We kind of assume that we did that to make sure that we can use these things. Okay, again, and I'll do this on the calculator with you. The margin of error formula I give you. This is your P hat, your Q hat. This is where your point estimate came in. Then you're going to take the square root. Oops, sorry. That's the other one. Your P hat, your Q hat. This is where your point estimate came from. And your N. Your N is how many in your sample. And your ZC is out here. N is how many in your sample. Some of you have a hard time with the N part. The ZC, which I have to multiply first, is the Z-score that's associated with your confidence interval. That comes from this. If I am 90% confident, my 90 falls in the middle. I am 1 minus 0.90 divided by 2. This goes in my inverse norm. At this point, all of you should be getting this. We've been doing this a lot. If it's 95, it's 1.95 divided by 2. I need to find that Z-score associated with this piece. Yes, it comes out negative, but I'm going to make it positive. There's also a little table on the bottom of table 4. When you get table 4, there's this little table on the bottom corner. And it gives you the 80, the 90, the 95, the 99. Those are the most popular ones. Okay. The next one, so we compared the intervals. And again, let's put this on a number line. I'm just going to put my proportion in here. 588, I'm going to put this here. So if I'm doing a 90, a 90 says this, 557 to 619. My other one says 551, which is over here, to 625. So the same rule holds. As the confidence level goes up, my confidence interval gets wider. Give me a little bit more wiggle room to be more confident. I need to have more confidence. Same thing like if you're going shopping and you need to buy something. And you say to your mom, can I have $25 so I can go buy this special pair of pants that I want, or this special shirt that I want for my date tonight? And she's like, well, okay, I'll give you $25. We'll say, well, could you just give me just a little bit more so I know I'll have enough money to pay for this? Don't you need a little bit more to know you'll have enough to be a little bit more confident that you can spend that much, a little extra? So it kind of works the same way. Give me a little bit more wiggle room and I could be a little bit more confident. Okay? parents always say, yes, but it's a good little ploy. All right? On your calculator, these work really, really nice. I'm a big advocate of the calculator for these. Stat, test, look for the word intervals, pull them up. We did your C interval, we did your T interval. We don't have two samples at all, but we have one proportion. And we do use the z-score with it. So this is the guy I want to use. It asks for the x, it asks for the n, and the confidence level. That's all it asks for. Now, sometimes what happens, and I'll see if it happens in your homework, where they don't give you the x and the n, they just give you the p. And you have to work it backwards. Did you have one of those? No, not yet. Okay. This guy, you had to find the sample size. Sample size, I'm looking for the n formula. So I pull out my n equals formula, and I fill this in. My margin of error comes from this, within. Within means 4% this way, 4% that way. Make sure you put your 4% in decimal form. We don't have any formulas that actually use a percent. There's no percents on your calculator, right? You can't say 4%. You have to say 0.04. When we start, we don't know any previous information, so our preliminary estimates is 50-50, 0.5, 0.5. Okay, find your ZC associated with your 95% and your margin of error. Now, remember, round up. No matter what the decimal is, round up. Then they say do it a second time. Now, a prior study. We've already run this before, so now we have previous information. Found that your p-hat is 48%. And we use 48 and the q, which is 0.52. And it should give us a little bit less. Now, if you take a look at this, and I ask you why are these numbers so close, what would you tell me? The other ones we saw were a little bit further apart. Why are these so close when they knew the actual? They know the actual percentage. Why are they still so close? God bless you. Thank you. Look what the actual percentage is. It's almost 50% anyway, right? So shouldn't I be just about the same answer? Yeah. I could be more certain now that this is right. Because before I wasn't certain. I still had to just go 50-50, middle of the road. I could be more certain now that I'm going to get a good sample. But it's almost the same because this is so close to 50%. Normally we see like a 32% or something different. But this is so close. That's why they came out almost the same. Okay. Another one, same thing. You have it within 5%. This is a pretty high margin of error. Within 5%, when you start, there's no preliminary estimate. You're 0.5, 0.5. Now look at the difference in here. You're a little bit less than this. 385 to 310, a little bit different. Okay. Can we all do this? Okay. Did I give you 21? Yes, this one was a big one. Okay, your information, did everybody get this one? These were all your ends up here. What Britain had, what US had, what France had, what Spain has. Okay, those were all your ends. And did they give us the X value or just the p-hats? The percentages? Did your book just give you percentages? What did you guys put in? It must be percentages, right? Okay, so now, here's a problem. If I go to put this into my calculator, I can't do this one. Because my calculator says I need the X and the N. So again, I'm here, I'm going to come down to A. It needs an X and an N. I know what my n is. I don't have an x. So how can I get an x out of this? How did we used to get a p hat? We said x over n. So reverse your thinking. How will I find my x if I'm given my p hat? I'm given my p hat. I'm not given my x, and I know my n. How can I find my x value? Multiply. Just take your percent and multiply by your n. Isn't that your x? So then you can still use your calculator. So just remember you can't have decimal people, because these are all discrete values. Just take 1044 times 0.69. You get 720.36. Now you can't put a 0.36 person in there. So just round it. Use your rules of rounding for this one. So round to 720. And I had 1044. I can still use my calculator for this. 99%. Here's my calculator. My calculator gives me my p-hat. Isn't my p-hat really close to 69? Did my p-hat come out real close if I round it? And here's my interval. Am I a little bit off? Actually, nope. This one actually worked just perfectly. It worked just perfectly. Sometimes you might be a little off in the rounding, just because you rounded up or down. Just show me where you rounded to. So you can still use your calculator for these guys. It works the same. Just take the percentage of your population, of your sample. Okay? Are we okay with these? Speak now, yes, no, maybe so. I wanted you also to get used to the formula a little bit so that you know how to use it. Know that you can use your calculator for these, but I always like you to try the formulas just for a little bit. Again, I want to be 99% confident that my population proportion will fall between these two numbers. I'm doing an inference about my population proportion. Sometimes it's easier to flip this to a percent. I want to be 99% confident that the people who consider air travel to be safe from my population will fall between 68.1% and 75.9% of my population. Not my sample. My sample, I know exactly what they did in my sample. I use my sample to make an inference about my population. Remember, in here is the population parameter. Okay? We good with this? Is there one more after this? One more? Or this was it? 22. 22. 22 was nice. It just asked you to put those on a number line and just to take a look at where they fell. That you can see some overlap in them. And usually that's what your margin of error does. It causes you to have some overlap. It should cause you overlap. And some of these, the percentages were a little bit higher, and some were low, but they should kind of have an overlap. It was easier for mine because I had all these different colors to do. This one was really a low one, the brown one. This one was a really higher one, and some in the middle just kind of overlapped. Who was brown? My France. France was brown. Spain was pretty high, and the U.S. was probably. Okay. Just so that you kind of see they can have overlap.